Hopefully it works this time. All right, guys, we're on page 42. We're starting section 2.5. 2 days of that. Then Monday's a work day and a homework check. What's nice about this work day, I think I mentioned it yesterday, is that there's nothing that you have to worry about on College Board this time. You could just focus on homework, questions you may have. So Monday's a great day that if you don't understand something we've been doing, I can give you lots of one-on-one help. That we're going to be doing some fancy calculator stuff today. Not fancy, but just have to know how to use a calculator. Maybe you're getting lost in the steps. You need me to sit with you on Monday and go through the steps with you, things like that. Okay? So just let's use Monday as a really, really valuable day for you guys, and then I'll do the homework check at the end of class on Monday. Okay? All right. So we are continuing with exponential function, context, and data modeling. Fancy talk for word problems, kind of, but pretty easy word problems. The hardest part of what we're doing in this section is being able to manipulate equations. It's really our algebra skills that are coming into play today, which is like being able to plug stuff in and then simplify for a missing variable. And so we work with like weird decimals and fractions and how do we put those in our calculators. There's a lot of that. So when we get to the calculator stuff, please do me a favor and do it with me. Don't just watch, because think about like how the last test, some of you were like, oh my gosh, I forgot how to like do the store the equation, the alpha trace, like you forgot how to do that. The more you interact with the calculators, the easier it's just going to be to remember all this stuff when it really counts. And so if you think about like how you guys are on your phone, you guys could probably pick up your phones right now and like if I said, where's your Snapchat, I don't know, whatever, you could go right, you would know exactly where it is without even thinking because you work with it all the time, all right? So we need our calculators to be like that for us too, okay? So, but let's first start out by reviewing something we already know, which is how to look at an XY chart and pull some information out that we need. Right here it tells you that this is an exponential function, and we need to write an exponential function that matches this data, okay? So we know we've been working with this for almost over a week already, exponential functions. And we know that A is our y-intercept and B is what we multiply by as we go left to right, okay? So A is your y-intercept, right there it is, right? Your y-intercept is whatever y is when x is 0. And sometimes you can look at the numbers and just tell what you're multiplying by. It's something really clear, so you don't need to do any kind of arithmetic to find it. But if you can't tell what you're multiplying by left to right, remember, you can test it right to left using division. So pick any two consecutive numbers, meaning right next to each other. Doesn't matter what two. If you put it in your calculator, 24 divided by 36. And then we have to know how to change a decimal to a fraction. Math, enter, enter. And so our B value is 2/3, right? And easy peasy, we can just plug that right in. 36 times 2/3 to the power of x. There's the exponential function that represents this. But I'm going to add to this something that I want to talk about, and that is how do I put in words that this is an exponential function? What did we just discover about this? Or let's pretend it didn't tell us it was an exponential function. If we had to say in words why this is an exponential function, there are specific like words we have to use. I'm going to write it. I would encourage you to write it as well. You have 3 of these homework problems in your homework, and all 3 times I wrote this whole paragraph. You don't need to do it in the homework. Let's just write it right now one time in the notes, and then and after I write it, I'll explain it. Input values are equal length intervals, and so we're talking about the input values, the x's, and the output values, which are your y's. Could you have said the x values or y values? Yes, you could have. We're just trying to use a little bit more varsity math language here, are proportional. Okay, and I'm going to explain that. I want to give you a second to write it. One of the benefits of me being a reader this past summer, a grader of these tests, was I know exactly how to grade the FRQs. I know what they will give you credit for and what they won't give you credit for when you take this test next summer. Next spring. I keep telling you guys, and I mean it, I already know the 4 FRQs. We know them. And I have lots and lots of examples of those FRQs that we'll work on in quarter 4 a lot. And I will tell you, you have to say this, but you could say this. You have to say this, can't say this. And we're going to I'm going to train you on how to get those points because I can tell you how to get them. You just have to do it on the test, okay, obviously. This is one of those things, being able to say in words what goes on in an XY chart. This first part, input values are equal length intervals. That's the same for no matter if we're talking about linear, quadratic, cubic, exponential. The X values have to have equal length intervals, meaning you're counting by 1 as you go left to right, or 2s, or 100s, but they have to be the same distance apart. If these numbers were all over the place, we wouldn't be able to name it as one of these special types of functions, okay? And then what's happening with the Y values? I know we keep saying we multiply by the same number called B, but the word is really proportional. So we're going to keep putting the word exponential and proportional together, seal it in our brain, and we'll come back to this later in the year when it really matters. I don't even think it's on our next test, but if it is, we'll revisit it. But this is something that I'm going to talk about quite a lot throughout the year because that's something that you're going to have to be able to kind of spit out. When you get to the homework, don't worry, you don't have to write this all 3 times in the homework. You can just find the A and the B and write the equation and be done. But it's written there, so I wanted to tell you that. Okay. Now let's get on to the algebra part of this. What? Oh, are you talking to me? No. Okay. So here we have an exponential function contains these 2 ordered pairs. Kind of like what we just had a second ago. We had an exponential function with a whole bunch of ordered pairs, right? We have 4 ordered pairs, and we had to use that information to find that. Well, here we have 2 ordered pairs, and we want to use those 2 ordered pairs to write an exponential function in that very specific form, okay? So we have 2 points, xy, xy, right? We have a function model that we're going to plug numbers in. G of x, of course, we know is y, right? G of x, f of x, whenever we write some kind of notation like that, no matter what the letters are, remember that that is your y value just written fancy, okay? So the first step is to write 2 equations using these points, and we're going to use them to do part B to find B and D. This is 100% one of your other FRQs. There's a FRQ, again, I'll train you on them when we get to quarter 4, but here's an example of you can get 2 points on the AP exam just by being able to do this part, which is really, really easy. Take your X and your Y and plug it in there. So I'll just do the first point first. My Y value is 6, then there's a 4, then there's a times, then there's a B to the power of X. X would be 0 plus D. That's it. I plugged the first ordered pair into the equation. That's equation 1. Let's make a second equation. Y would be 10, or is that 110? Thank you. 110 equals 4 times B to the X value in that ordered pair is 3 plus D. So that's what we mean when write 2 equations with those points. We have a model, we plug them in. Equation 1, equation 2. Now we're going to use these to find B and D, and then we'll plug those numbers back in. But we'll get to that in a second. Let's do this part. Find the values of B and D. Well, let's just take our first equation. What I can see already that I can simplify is B to the 0. What does B to the 0 equal, guys?
1.
1, right, Daniel? Anything to the 0 power is 1, whether it's a number or a letter, okay? So let's just go ahead and simplify that. 4 times 1 is 4. And then we can subtract 4. You do not have to show that step of subtracting 4. D would be 2. We found D. Whatever you find in your first equation, we're going to plug in to the second equation. Where do you think I plug D equals 2 into? Here, right for D, right? So I'm going to plug 2 in for D into my second equation. And now I'm going to solve for B. So this is where your algebra skills come in. Wait, what do I do first? What do I do second? There are rules, right? What would be my first step? Minus what? No. Minus 2, right? We're going to subtract. Order of operations, we multiply and divide first, but when solving an equation, we add and subtract first. So that's a little confusing. And you're used to, you won't get that wrong. I don't think so. Now we would divide by 4, right? Divide both sides by 4. Nobody's questioning me. No one's like, wait, why are you dividing by 4, right? We learned a long time ago that to solve an equation to get a variable by itself, you have to move everything to the other side following those rules of do the opposite, right? So 4 and b next to each other means multiply. The opposite of multiplication is division. So that's what I did, right? I divide both sides by 4. That gets me down to b to the 3rd. I put 108 divided by 4 in my calculator. Trust me, I got 27. Did it in my calculator. And staying on that, remember, I want b, not b to the 3rd. So I have to do the opposite operation to get b by itself. The opposite of cubing something is cube rooting it. So I'm going to do the cube root of this side. Don't forget, golden rule of equations. What you do to one side, you must do to the other. And there's a couple different ways you can do cube roots in your calculator. You can go right to math. Turn your calculator on, go right to math, and it's number 4. You can see the cube root. Or you can put the root on your screen first. So I want a cube root, so I'm going to put a 3 in. And then you can go to math number 5. See how there's an X there? We already told the calculator that we want a 3 to go there, and that's another way of doing it. Okay? So 27 is 3. So we just found B and D, right? Here they are. And our final answer is just rewriting this, plugging in the b and the d. So our final answer would be g of x equals 4, and I can use the dot, I can use the parentheses, either way, it doesn't matter, to the power of x plus 2. Notice in my final answer, I don't plug anything in for x or y. That's always the case. When we write a final answer in function form, you don't put anything in for x or y. Think about slope-intercept form, the most basic one that you guys work with, y equals mx plus b. You plug in a number in for m and b, and that's it. You leave x and y as x and y. Okay? We'll do another one in a minute of those, and I'll do another one in your homework. Okay? Because those take a little practice getting used to it, and this one was pretty easy. They get a little bit harder. All right? But before we do that, we're going to work with some word problems for a second. Here we have exponential growth, doubling time formula. This is not a formula you have to memorize. Don't worry about it. This is the type of word problem you would be given the equation, and you would just have to know how to work with it. And they're being really nice here, giving us the formula, if you will, and then telling us what all the letters mean, okay? So the size of the population at t time. So P of t is the population of something. With the initial population is P sub 0. That should make sense. It's in that A sub 0 spot, right? Our y-intercept would be P sub 0. If you're doubling something, you're multiplying it by 2, right? So that's why my B value is 2. Double is multiplied by 2. And then it says the doubling time of K is given. So T is time, and K is how often it doubles. If something doubles every 5 months, K would be 5. Okay, and those kind of things. And so let's look at the next page where the example is that we're going to use this, and I'll rewrite that formula at the top so we can look at it. Hey guys, come on. Okay. I hope I sounded mean. Let's try. It's hard for me to be mean, but believe it or not. Okay, so that's the formula. Let's see what we have. A certain fish species was introduced into a tidal basin 10 months ago. I'm sure I'm going to have to use that 10 somewhere. The current fish population is estimated to be 220 and is doubling every 5 months. Okay, so let's start breaking down all this stuff. In any order, I'm going to pull out some variables. B is going to be 2. Doubling. That's already given to us. Okay, fine. K is how often it doubles, which is 5 months. Okay? Now, this 220 is what happened 10 months ago. That's not our initial amount. Okay? Time is 10 months ago, doubling every 5 months. And then what we actually have is a sub 10. So that should be a p sub 10. Sorry, that's a p. P sub 10, we have in 10 months, it's 220. What we want to know is what the initial is. So we have all the variables in this equation except for p sub o. Common mistake here would be to think that 220 was initial. But that would be with time 0, and they said time is 10 months. So we're like, here we are at 10 months later. What was the starting amount? So let's plug these numbers into the function. So here's our algebra stuff we have to deal with. We have to know how to solve for p sub o, meaning get everything that's on the right side over to the left side correctly, okay? So right away, I would think you guys agree with me that 10 over 5 is 2, right? So what that means is the population of fish doubles every 2 months. So if you take, it's going to double twice, because in 10 months' time, it doubles every 5 months. So in a 10-month period, it's going to double twice, 10 divided by 5, right? So I have 220 equals p sub o times 2 to the second power, which is 4. It looks funny, but we should understand what those symbols mean. This is multiplication. To get that by itself, I would divide. So the initial population is 220 divided by 4, did it right in my calculator, 55 fish. Something I should, before I walk away from a word problem, see if it makes sense. So at 0, I started with 55, and 10 months later it was 220. Does that make sense? Yeah, because as we go forward in time, we double, we're getting bigger. We're going backwards in time, we get smaller. Good? Estimate the population of the fish 1 year. So 1 year would be 12 months. We're talking about months here, so we have to stay with the same time. Okay? So that's like, what is, if time is 12, what is the population? Okay? What is y when x is 12? We can just plug it in. So p of 12 equals, okay, what's my p sub 0 is 55. B value is 2 to the power of, we're going to put in 12. Remember, that's our t value. Divided by what? Divided by what? 5. Yeah, testing me. I just put that right in my calculator. 55. I'm going to just use parentheses times 2 to the power of 12 divided by 5. And that would be about 290 fish. Right? So notice, when we have x and we need y, we can just plug right into the equation. What happens when we have y and need x? That's what this next problem is going to be. Also, new formula, without that whole paragraph that explained what everything means. But we should start being familiar with what some of this stuff means. Suppose the half-life of a certain radioactive substance is 40 days and there are 8 grams present initially. 8 grams present initially, that's probably an important number. Find the time, that's what we want to find, when there will be 1 gram. That'll be an important number too. Okay, so half-life, I know it's popped up before and some of us had questions about it. Half-life is a big concept in chemistry, especially chemistry, because there are chemicals that have half-lives, okay? For instance, if I have 100 grams of something and it has a half-life of 3 months, that means every 3 months it goes down by half. I don't know what happens to it. Some sciencey word, let's call it evaporation, I don't know. But you have 100, and then after 3 months, I have 50. After another 3 months, I have 25, and it keeps going down, 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 okay? So that means we will have a B value of 1/2. What is this 1 plus R business? Remember, B is 1, and I like to put plus or minus R. So our half-life is really 1/2 is our R value. We would subtract for 1. That's decay. Our B value should be less than 1, so it's subtracting. Okay? So B is 1/2. Every 40 days, it should make sense to us after we learned that last one that K would be 40. 8 grams initially, that's A sub 0, right? Initial amount is 8. And they want to know time when A sub T is 1. When will we have 1 gram left? How much time? So basically, we're plugging a 1 in here. This is 8. This is 1/2. T is what we don't know, and K is 40. How do we find T, or X, when given Y, right? We don't know X, but we have Y. That's when we have to go to our graphing calculator and use the intersection, okay? What we're going to be looking for is where do they intersect. So this is Y equals 1, horizontal line, and whatever this X value is, that will be our time. What time do we get to that? So we've done this before. Let's clear our RAM. Please clear it because it's probably got the right information in there from last period, but you want to do this from scratch yourself. So everyone should be picking up their calculator and going to Y equals. And so this would be our first equation, right? The 8. So 8, I'm going to use 0.5 because it's faster, to the power, we don't have X, but we have T. T and X are the same thing, divided by 40. So there's Y sub 1. What am I putting in Y sub 2? 1. We want to know when the time is, what time we have 1 gram. How many months? Or days, I should say. It's days. All right, so we graph it. And what we want to know is the intersection. But remember, to be able to find the intersection on a graphing calculator, you have to have it on your screen. So this is when you get to play with your window. And you can't be afraid to go change your window a bunch of times. Because remember, if you were taking this test or something on a test, I'm not going to tell you what to change your window to. When I look at that, I can see, like, I know this is decaying 1. It's going to be over there somewhere to the right. That's X max, right? I don't even need all this part of the screen, but let's just play with it. I'm going to go X max. How do I know what to put it on? The answer is I don't know. I don't know initially. I mean, I know my answer, so if I have the answer, yes, I could make my calculator go over that far. But I might start by saying 100, and I'll look and I'll see, okay, we move to the right. Let's see, are we going to see the intersection? Not quite. So what do I put in there? I mean, you could get really aggressive and put 200, put 150. I don't know. Pick what you want. Okay? And sometimes you might have to play with it a little bit. I actually am guilty of playing with it too much and then just being like, I can't even tell what I'm doing anymore. And even though I know I'm intersecting somewhere there, my picture's not great. I could get a little closer. I could change my X min. Let's maybe change that to 0. Maybe I don't want all that space at the bottom. Maybe I could just change. I'm playing really at this point, okay? There's no one way to put your window to make it be perfect. And by the way, I don't need it to be perfect. That ain't perfect, but I can see approximately, look at my pen, somewhere in there, right? Somewhere in there. So I'm going to let my calculator do the real hard work for me right here. I'm going to go to calc, and number 5 is intersect. And I want to say always, I hate to use like final things like that, like always, but I feel like it always, that first one is always in a good spot. It's always to the left, first curve. I don't even need to mess with it. I'm just going to hit enter, and it like stamps the spot. And then your cursor jumps to the horizontal line, and we use our right arrow, and we just want to get to the other side of it. Does it have to be right after it? No. So I'm being really careful. I'm going way to the right here, so I make sure I have passed over the intersecting part. Look at my hands, guys. They don't. Your 2 points don't have to be this close. They can be this far apart, and your intersection is somewhere in the middle. That's what I'm doing here. I'm letting my calculator figure it out for me. okay? So that's why I'm just kind of going over to the right. I didn't spend another 10 minutes on my window to make it perfect because it doesn't have to be. Hit enter. After you hit enter?
Yeah.
Yep, it did that for me too. When I hit enter, it like stamped that point right there. And then when I hit enter, it jumped. It always will. It'll jump to your horizontal line. And then that's all I did is I moved my right arrow over till it was far to the right.
Well, no, I guess I moved my right arrow and took the first point off of the line.
Oh, you must not have, okay. I don't know. Well, I'll come do that one with you then in just a second. So I already hit enter, so I stamped it right here. So the calculator is saying, are you ready now? You want me to guess? And I'm going to say, yes, I do, by hitting enter again. And you can see y is 1. That's what we want, right? When x is 120. All right? So we get 120. What am I saying again? 120 days to get to, what are we saying? 1 gram. So sometimes I have to go back and read so I can label it correctly. If this was an FRQ, you wouldn't just want to say 120, okay? You'd want to kind of give a complete sentence, something like that, okay? All right, one last question, and that's to do those 2 equations again. Fancy algebra. We're going to get really fancy in this algebra problem. We're going to use lots of fun buttons that we've already learned on our graphing calculator, so please do it with me, all right? Dan, you will be the first person I come to right after this, okay? All right, so let's do our last example, and then I'm going to do a little bit of the homework with you, and then you'll have a little bit of time to work, but don't forget, you have Monday to just work on the last few problems of any homework if you don't want to do it as homework, okay? All right, given 2 points, we're going to write an exponential function for the graph. So we're given xy, and here's the graph of it. Who cares? But what we're going to do is write an exponential function. They didn't give us like a model for it. Like remember how that one had an A already built in, it had a D. This one doesn't, so we just use our generic basic exponential function. I'm going to write an exponential function, which means I need A and B. That's what I'm going to have in the end, right? So let's start by writing 2 equations. I'm going to plug x and y in to this one. Right, there's my first equation. And then my second equation, I'm going to use I'm going to use 0.5 instead of 1/2. You can use fraction or a decimal there. It doesn't matter. Right, so I plugged in x and y. That's writing the 2 equations. And then what we do is solve for a. You solve for a first. So I'm going to get a by itself. But before I do that, now look, there's the problem in the homework, there's only one that you're going to have to do by yourself, is just like this. It has a negative exponent in it. Let's make it positive. How do you make a negative exponent positive? You put it in the denominator. And then you can just put these together. That's a over 1 times 1 over b to the 5th. Guys, you can multiply with unlike denominators. You get a over b to the 5th. And let's do one more thing to get a by itself, which would be multiply both sides by b to the 5th. So here I got a equals 12b to the 5th. Okay? Now, I take a, I plug it in. So whatever you get here, you plug into the other one. We got, I think, d first on that last equation, so we plugged in the second one. Now I'm going to plug this value in for a. So I will have 0.5 equals right there is this, okay? Just replaced a with that. Here it is. And remember, to simplify this, when you have like bases of multiplication, you add your exponents. So 5 plus 6 is 11. What now? Divide by 12. Yep. So in my calculator, I go 0.5 divided by 12. And I get nastiness. Anytime you get nastiness like this, try and change it to a fraction. If we're lucky, it gets changed to a fraction. If not, we have to be really fancy, which we'll have to do in a minute, but not yet. Because look, math, enter, enter. We can write it as 1/24. Why is that better? Because I would have to round to write this decimal. We don't want to round into the very last step if at all possible. Okay? So 1/24 is what we're going to write. That is important. Always try to change those crazy decimals to fractions. Equals, so the 12s cancel, b to the 11th. Now remember, we had one a few minutes ago, it's like b to the 3rd. How do you get the b by itself? We did the cube root. We're going to do something really weird in here, but the calculator is going to handle it for us, which is doing the 11th root. It's weird, right? But that's how you would get your b. So I have to do the 11th root to this side. So again, how do you do an 11th root? You put 11 on your screen first, then math 5. And you can see an 11th root right on your screen. And I get another yucky decimal. So we always want to try math, enter, enter with those. And sometimes, like right now, we can't make it a fraction. That's called an irrational number. A decimal that can't be written as a fraction is irrational. So, but we're at the find. There's nothing else for us to do to find b, so this is when we will have to round. So we will round to 3 decimal places, 0.749. Right? But now I still need a, right? I'm going to plug, pay attention here, I'm going to plug b in right here, right? That's not foreign concept to any of you. You're going to put b value there. But I'm not going to put my rounded answer. Guess why? I'll get the wrong answer. Anytime you have irrational numbers, you need to work with them in the state that they are until the very last step, and that's when you round them. So how do we do this? It's really, really simple. Don't I want this number to the 5th power? B is the number on my screen, right? This is B. All I have to do is hit my exponent key in 5. My calculator, look what it says, ANS. It knows that what I'm telling it to do is to do the most recent answer to the 5th power. I don't even have to type it or anything. The whole point of this is you can't type it. It goes on forever. Your calculator knows it. We don't, okay? So you hit enter, and you get another crazy number. But we're not done, right? B to the 5th is this. What's our last step to get A? Oh, and I just missed it. Multiply it by 12. And I'm just doing it all. You don't have to write all these steps out. This is meant to be done on your calculator. Times 12, and now I'm at the end, so I would have to round that to 2.83. There's a 0 there. You can write it or not, but if your 3rd digit or your 2nd digit is a 0, you can just drop it or keep it. Doesn't matter. So our final answer would be 2.83 times 0.749 to the power of x. So we have to be able to use those little features on our calculator, okay? What's the y-intercept? No, it's not 0.749. Yeah, remember, it's a trick question. It's just trying to trick you. We can't be tricked. The y-intercept is your a value. Remember that. Okay? Tomorrow, we'll use technology to write an exponential regression function, and we can do this in 5 seconds. Literally, like 5 seconds. As fast as you can type 2 points in your calculator, you can get your answer. Why didn't I teach you that first? Because you have to know both ways. So we'll do the easier way tomorrow. On a Friday, you'll love it. Tomorrow's notes are nice and short and easy. All right, let's go to the homework. I'm going to do 1 through 4 and 8 with you, okay? Page 49. Oh, sorry, sorry. Where is it? All right, 1 through 4 are asking for, without graphing, determine whether the function represents growth or decay, find the y-intercept. We're also going to find r. because I need to talk to you about that. So I'm going to do all 4 of these with you because R and B are 2 different things. All right. So let's talk about this. If your B value is greater than 1, that's growth. Okay. Your Y-intercept, we just talked about it, is the A value. Okay. Easy, right? What is the R value? Meaning, if I gave you a word, we're kind of working backwards here. If I gave you a word problem and it said your rate is some percent, remember percents are your rates in these word problems? What would it have been before we plugged it in? Remember, to get B, we're doing that 1 plus or minus R. So what would our R value have been in this problem? Yeah, which becomes 34%, right? So in the word problem, it said something about 34%, and you said, oh, it's growth. It's like your car is gaining value, or your diamonds are increasing in value by 34%. You would add 0.34 to 1, and that's how you would have gotten that, okay? So we're kind of working in reverse here. Look at the next one, 5/3. That's an improper fraction, and I meant to skip to 3, by the way. Sorry, couldn't really say that. 5/3 is an improper fraction, so just knowing that it's improper means it's growth, but we're going to have to know what it is in decimal form anyway, so I'm going to go ahead and do that. So that would be 1 point, let's just call it 67, right? So Y-intercept is 0.7. So when I change it to a decimal, you could clearly see that that was growth. That's greater than 1. What would our R have been? 67%. That's right? Because you would have changed it to 0.67 and added it to 1 to get your B value. All right? So growth is easier than decay. So let's talk about how to do the decay ones. All right? This is going to be decay simply right away because 1/5 is less than 1, right? So that's decay, and of course our Y-intercept is 0.6. But our R, what would that be? Well, first let's change 1/5 to a decimal. So 1/5 is 0.2. So what would my R have been? It's actually 80%. Why? Let me show you. 1 minus the 0.2. So think about it. Our word problem says you just bought a car and it's going to lose 80% of its value every however often. Losing 80%, but what are we keeping? What math are we using? We're going to keep 20% of what we started with. That's what that means. So decay is tricky. Yes, it's 100% minus 20%, which is 80%. Or you could change them both to decimals, which are 1 and 0.2. Either way, whatever you want to think of. Last one of these is when you have a negative exponent, it's not in the right form, right? It's fine, but to be able to evaluate what we're doing here, we would need to change that 3 to the negative x to a positive x. So that just moves the 3 to the denominator, because the 3 is like you could think of that as 3 times negative 1 times x. So the 1/3 is what this becomes, and the x is still up there. And that is important to see, to know that this is decay. Everybody's been getting this wrong today. What is the Y-intercept in this problem? 0 what? No. Y-intercept is your A value. What's our A value? 1. Remember, the number that has a power is your B value. A is the number in front. If we don't see a number in front, it's 1. Okay? Remember that. All right, so if I change 1/3 to a decimal, I get 0.33 repeating. So what would my R be? 1 minus 0.33. Good, 67%. Decay, those are the trickier ones. Okay, what you would read in the word problem is the R. You would convert it to B by either adding that or subtracting that from 1. Growth you add, subtract for decay. Okay, 5, 6, and 7, skip them for right now. I'm going to do a harder one with you. This is where you identify A and B, identify the A and B and put it in the equation, guys, and you don't need to write that paragraph. Remember I told you about that? I wrote it 3 times. You don't have to write it at all unless you want to practice. Let's do number 8, which is writing an equation. Get rid of that D in this form. Okay, so we're going to write an equation in that form, which means I need A and I need B. And all I have is a bunch of X and Y's. So just like we did before, Y equals A times B to the X, and Y, which is 1, A times B to the 5th. There's my 2 equations, plugging X and Y into the model. Let's solve for A in our first equation. This one's pretty easy, right? Divide both sides by B, and A is 16 over B. Then we take A, plug it in right here. So I would have 1 equals 16 over B times B to the 5th, right? So I just took this and put it right there. And again, we can put these together by multiplying them. If it helps to put a placeholder there, that's fine. But that B to the 5th is in the numerator, so it's 16 B to the 5th over B times 1 is just B. There's a 1 on this B. You don't see it, but you know it's there. We would minus them, subtract them, yes. So we get 1 equals 16b to the 4th. And I'm showing these steps, like you could totally not show that. You could have gone right to 1/16 equals b to the 4th. By the way, 1 divided by 16 is a terminating decimal. What I mean by that is it's not going on and on forever. I could write that as my 1/16. Either one, they would be fine. This is a good decimal, not a yucky one. It changes back to a fraction. That's how I know it's good. Okay, so either one. And remember, you need to get b by itself, so we would do the 4th root of both sides. Again, I already have the number on my screen. I'm going to do 4 math 5 to get my 4th root on there. And remember, you can use your second A and S button if you don't want to type it again. It knows to take my most recent answer's 4th root, which is 1/2 or 0.5. I have B, what's A? It is 32. How did she get that? She put 1/2 in for B, so 16 divided by 0.5 is 32. So A is 32. Here's your final answer. 4th root of 1/16. Okay. So I only gave you one more of those, which is number 9. So one of them to do by yourself. Tomorrow you learn how to do it on the calculator, but you have to know both ways. So. Did you get that, Christian? Let me. He's also on Canvas. Daniel, clear your RAM and let's do that problem together real quick, if you don't mind.
Shark thing, like, yeah,
A quick question.
Sure.
Continuity, that's just like concave up or concave down.
No, concave up, concave down.
Yeah.
Continuity is, do you connect all the, does it make a smooth curve? All of the exponential functions have continuity. So you would say yes to continuity. When do we not have continuity?
If there's like
Just the point. Or yes, or if there's a hole. You're exactly right. But remember in 2.1 and 2.2 when we graphed the sequences, it was just a point, a point. We didn't connect the dots. If you go back and look at 2.1 and 2.2, those are not continuous because they are not connected. You don't use all the points in between. Does that make sense?
yeah.
Okay. Mm-hmm. Late homework, yes, but not late quizzes or progress monitoring. But yeah. Uh-huh. Yeah, I do. For half credit, you definitely can, better than no credit, right?
All right, have a good one.
You too, Daniel.